Hi, my name is Andrii Matviienko and I am from Technical University of Darmstadt, Germany. On behalf of my co-authors, I'm going to present to you our work titled SkyPort, Investigating 3D Teleportation Methods in Virtual Environments. While virtual reality environments allow for infinitely large spaces, the physical movement of the user is limited by the boundaries of the tracking space in the real world. This effectively rules out our natural modes of locomotion, such as walking in VR to cover longer distances. Researchers have attempted to address this challenge by introducing artificial locomotion techniques which typically facilitate two main types of movement in virtual environments: discrete and continuous. The most notable discrete locomotion techniques is teleportation, as you can see on the left-hand side, which allows users to arbitrarily cover virtual distances in jumps without moving in the real world using controllers, gates, or static portals. Continuous locomotion, on the other hand, allows movement through virtual environment via flying, independently from physical constraints and gravity compared to 2D ground-based locomotion. While continuous movement is adapted for locomotion in both 2D and 3D space, it often leads to an increased VR sickness. On the contrary, discrete movement is predominantly restricted to the horizontal 2D plane or predefined 2D planes. Therefore, the question is how discrete 2D locomotion techniques can be extended to 3D space. In other words, to teleport to any point in 3D space. In this work, we aim to advance teleportation from the horizontal 2D plane to 3D space. For this, we focus on techniques that facilitate aiming and transitioning to a target. Existing teleportation methods in virtual reality primarily focus on teleportation in 2D space. However, bringing these teleportation methods to 3D space poses two challenges. The first challenge is related to explicitly setting the teleportation point in 3D space. To mitigate this challenge regarding the selection of the teleportation point, we overlaid the touchpad of the controller with a scale in longitudinal axis, where the pressed point of the axis lies between 0 and 1. So in this way, users can choose closer distances by touching a bottom close to 0 and further distances by touching the top close to 1. The second challenge is related to the relative placement of the user to the teleportation point. To mitigate this challenge, we use the teleportation point at the target position of the controller. However, this way the teleportation would allow the user to fall to a height below ground level when targeting a point below the user's hand height. To address this, we compare the real ground level adjusted with the settings of the VR setup with the ground level of the virtual environment and kept the latter to the level of the first. So speaking of the aiming methods, we looked at the two traditional methods of teleportation, such as linear and parabolic aiming. To keep both methods comparable, we aim to limit them to the same maximum distance of 18 meters, while for the linear teleport, this constraint implies simply setting this value. For the parabolic teleportation, we derived the maximum distance by computing the projectile distance at the angle of 45 degrees of the controller to the ground. As for the transitioning to a target method, we look at the three different possibilities. So the first one is called instant teleportation, and as soon as teleportation is triggered, the participant view is faded out for 100 milliseconds. The actual teleportation takes place and the view fades back in another 100 milliseconds. We chose this method of instant displacement as a baseline. Alternatively, we investigate a continuous linear method to a target, which leads to a better orientation in space and a higher feeling of presence. Finally, we propose an interpolated type of movement with the teleport. On a trajectory leading from the current position to the target position, we calculated 4 equidistant points which the user will be teleported to. The user experiences 4 intermediate stops between arriving at the final destination in a similar manner to the instant teleport. This was meant to be an intermediary step between an instant and continuous movement while allowing for peripheral vision. The combination of two aiming methods and 3 types of movement led to 6 3D teleportation methods in virtual environments. Also, we accounted for target direction and distances. So the combination of 2 independent variables provided us creating different trajectories for collecting coins in the user study. So each subsequent coin was randomly spawned in 5 target directions: left, right, up, down, and front. And also we looked at the 3 types of distances, which is 7, 14, and 21. To test 6 teleportation methods in a fully 3-dimensional navigation task, participants had to collect coins in the virtual space as quickly as possible. At the beginning of each trial, participants were shown 2 coins, the one to be collected, active, here shown on the left, and a consequent one overlaid with a red cross, inactive, shown on the right. The coins were collected by pulling the trigger when holding the controller not further than 1 meter away from the active coin center. The maximum distance was set to avoid accidental triggering. The active coin center was marked as inner white ball with a diameter of 10 centimeters to avoid misestimation to its exact position. To compare the proposed 3D teleportation methods in VR, we measured the following dependent variables. Coin collection time, so the time necessary to collect each individual coin. Coin collection offset. For each coin, we measured the distance between controller and the center of the coin after each last teleport. Number of teleportations, so for each coin we counted the number of teleportations necessary to reach the target. Virtual reality sickness, present errors regarding ease of use and frequency of use. So we found that linear target aiming combined with instant transitioning has the highest performance in mid-air environment in terms of speed and accuracy. We discovered that participants were faster collecting coins using linear than parabolic methods. As for the type of transitioning, instant was shown to be the fastest, followed by continuous and interpolated types. We discovered that participants achieved the shortest coin offset using the instant type of transitioning compared to the continuous and interpolated methods. As for the number of teleportation, we discovered that participants require a smaller number of teleportations to reach the target using the linear than parabolic aiming method. We also observed many differences in terms of distance and direction, but due to the lack of time, I won't go into detail here and would ask you to refer to the paper. In general, we discovered that teleportation using linear target aiming methods outperforms the parabolic one in mid-air environment. Moreover, instant transitioning to the target was the fastest and the most accurate. Therefore, linear target aiming combined with instant transitioning is shown to be the most efficient teleportation method in 3D without causing VR sickness. Distant targets reduce the speed and accuracy of teleportation in 3D. As our results have shown, the further the object is from the user, the longer it takes to reach it. The same is true for the number of attempts and the size of the offset. So, to summarize our work, in this paper we propose 6 teleportation methods in virtual 3D environments based on the combination of linear and parabolic aiming and 3 types of transition in instant, interpolated and continuous. We conducted an experiment to investigate the performance of the proposed methods and discovered that combination of linear aiming methods and instant transition leads to faster and more precise target selection without inducing a high level of VR sickness. Additionally, we found that teleportation downwards is more challenging and requires a high number of teleportations. Lastly, our results have shown that the linear aiming method leads to a lower number of teleportations than parabolic for tested distances to the target. With this, I would like to end my talk and thank you for your attention.